In this video, we are going to study about the applications of using the normal distribution. So recall that a normal distribution is a distribution that has the bell curve, and the curve is symmetric. The mean is at the center, and the mean is also the median, because this is most of the value will occur at this point. And we learn how to convert from the normal distribution to the standard normal distribution using the z-score, the z-scale, where the z-score formula is given by x subtract the mean divided by the standard deviation. And if you are using the z-score, the center has the z-score of 0, and we can apply the z-score table to find the area under the curve. If we don't have the calculator, if we do have the TI-84 calculator, then we do not have to convert it to the z-score. You can also find the value of x if you are given the z-score. So a few of the problems we'll see in this video will deal with the problem where you are given the area and you are asked to find what is the value of x. So we can solve for the value of x in the equation by multiply both sides by sigma. So we multiply sigma on both sides, and then to solve for x, we add the mean mu to the right and the left side. So we can find the value of x by multiply the z-score to the sigma or the standard deviation, and then add to the mean. And given a normal curve, when I write p of the random variable x is less than a particular value of x, I'm looking for the probability that we are getting a value inside this interval. Okay, let's go over the first example. A study reported that the length of pregnancy from conception to birth is approximately normally distributed with a mean of 272 days and a standard deviation of 9 days. What proportion of pregnancies last longer than 280 days? So in this case, remember that we are given the normal distributed data, so we can apply the formula from the normal distribution. So let's draw the curve and then write out what we got from the problems. So we know that this is the normal curve, the normal distribution. We have the mean to be 272 days, or that should be the center. And then we are asked, what is the proportion of the pregnancies last longer than 280 days? Or what should be all the value bigger than 280, or we are looking this proportion or the area under the curve from 280 and above. Now one of the ways that we can do is we first convert it to the z-score. This is the x scale. Now we need to convert it to the z-scale. When we convert it to the z-scale, the means becomes 0. And how do I convert 280 to the z value? We can do that using the z-score formula. X minus the mean divided by the standard deviation. The x is the value here, which is 280, the one that you are looking to convert to the z-score. Subtract the mean and divide by the standard deviation. We are given all from the problem, the mean and the standard deviation. So we make the substitution here, and then we are able to find the z-score. So 280 has the z-score of 0.89 on the z-scale. And then from here, we can go ahead and we get out the positive z-score. We are looking for 0.89. 0.89. So let's take a quick look at this z-score table. 0.8 is right here, so we need another 0.09, which is all the way at the end. So 0.8 is right here. That should give me 0.8133. And remember, that is the area to the left side of that z-score. Remember, that is the area to the left side of this value. So 0.8133 is all the area to the left side of that z-score. But we are not looking for the left area. We are looking for the right area. And how do I find the right area? Remember, everything here, the whole curve, has the area of 1. So we have this particular value. You can take the whole thing 1, subtract this particular region to get the red one. And that should be 0.1867. Or this is the proportion of the pregnancies that last longer than 280 days, or 18.67% in percentage. Move 2 places to the right. Another example. We have to combine the verbal and quantitative reasoning score on the GRE. This is a graduate study admission score. And this score is normally distributed, so we know that we can apply the normal curve in this problem. We also have the mean 1049, that is the mean value, the mu, and then the standard deviation, which is sigma. Now they ask you, what is the score of the student whose the percentile rank is at the 85 percentile? So let's first draw the curve and see what they are looking for. Now we know the mean and the standard deviation, which is the center. We are looking for the score. This is the X scale. We are looking what is the score right here that corresponds to the 85 percentile for the rank. Remember, the whole thing all the way to the right is 100%. All the way to the right, this is 100%. We are looking for 85 percentile, which is 85%. What is the score right here that gives me at the point where we get the 85 percentile? So what is this X value? Firstly, I can use the standard normal distribution to convert to the z-score. This is the X score, X scale. So z equal X subtract the mean divided by standard deviation. We got these two values, but we don't know the value of X. We also don't know about the value of Z, but you are looking for the value of X right here. So we go ahead and we solve for the X term. So multiply both sides by sigma, which gives me this one, and then I add the mean on both sides. So in order to solve for X here, I need to have the Z, sigma, and the mu. I got the sigma and the mu, but not the Z score. So how do I figure out the Z score in this problem? Okay, we convert it to the Z scale. When we are at the Z scale, the Z score at the center, the mean, is 0. Now we are looking for 85 percentile. What is the value of Z score right here? 85% means 0.85. So what is the corresponding Z score to this 0.85? Well, this is the opposite problem with what we saw earlier. So we are given the area, we are looking for the Z score. So this is the positive Z score. So let's use the positive table. Now we know that we are looking for 85%. That is the number inside here. So let's try to locate the 85%. 85 is around here. This is 85, 85, 99. Let's try to find the smallest value of 85%. This is 84, so the smallest value of 85 we can have here is 0.8508. So this is the 85 percentile, and this is the value inside the body is the the value of the area. So we are looking for what is the corresponding z-score of this area right here, and that z-score of that should be 1.0. so 1.0 together with a column of 0.4. so 1.0 and 0.4 is 1.4. so 1.4 is the corresponding value of that z-score that has the area of 85% or 0.85 to the left side of that z-score. Now we can also use the TI-84 to find that. Now because we are given the area and we are looking for the z-score, now we can use the function called the inverse norm. So second, vars to get you the distribution. We use a function called inverse function because we are doing the inverse process of the normal distribution function. So the area here is 0.85 to the left side of that z-score. And then the mean is 0, standard deviation is 1. And it gives me 1.04, which is what is we got earlier from the table. So 1.04 is right here. Now, after we have the z-score, that is all we need to find the x value. So I do now is I plug in the z, the standard deviation, and the mean. So I got the value of 1246. So the score of 1246 is the score of a student whose the percentile rank is at the 85th percentile. So that's another topic called significance. So we normally use the probability to find whether a value is significantly small or significantly high. So as a rule of thumb, if the value of the probabilities of x is lying inside the top 5% or the bottom 5%, we consider that to be a significantly high or significantly low if they are at the lower 5% bottom of the curve. And then there's a quick review of the notation of the z of alpha. So if we are using the z-scale and we are using the area of the curve, now when we write z of alpha, the subscript alpha here represents the area to the right side of that z-score value. Okay, let's take a quick look at the last example of this video. A national study found that college students with jobs work an average of 22 hours per week. The standard deviation is 9 hours. So we have the mean. In this case, the average value is the mean. So this is the mean value, the mu. And then the standard deviation, this is the sigma value. A college student with a job is selected at random. Find the probabilities that a student works for less than 4 hours per week. Assuming that the length of time the college students work are normally distributed, so that is the big keywords here, and are represented by the variable x in this case. So let's check out the solution. So we know that this is a normal distribution, and therefore you can apply the normal distribution curve. We know that the mean is 22, that is the center, and the standard deviation is 9. And they ask you, what is the probability that a random student that is selected has the number of the hours is 4 hours or less than a week. So we are looking for the value of less than 4 hours. So let's first convert it to the z-score so we can apply the z-scale. Now z-score is equal to the x value minus the mean divided by the standard deviation. We are looking for what is the corresponding value of the z-score when the x is equal to 4. So 4 is your x minus 22, which is the mean, divided by the standard deviation, which is equal to minus 2. So now you are looking for the value of the area that has the area of that has the z-score of minus 2. Or if you look at this way, we got the normal curve, we got the z-scale, and now we found that the z is at 0 when we are at the center, when we convert it back to the z-score, and when we are looking for less than 4 hours, the limit that we are here when we are less than 4 hours, that value right here has the z-score of minus 2 because we are on the z-scale. So we found it to be minus 2. So minus 2 is the limit that we are looking for. Okay, so minus 2 is right here. So what is the portion below minus 2 for the z-scale? So we can find that using the standard normal table, or you can use the TI-84. So let's try to use that. This is the negative z-score minus 2. So we can go ahead and we take out the normal standard normal distribution, and we are looking for the exact value of minus 2. So minus 2 is right here with the 0, 0. So this is the exact value of minus 2. So minus 2 is right here. So 0.0228 is the area to the left side of minus 2. 0.0228. So that is the area right here. 0.0228 to the left side of that minus 2. And then we can make the conclusion that the probability that a student works for less than 4 hours per week is this number, 0.0228. Or if you convert it back to percentage, you should get 2.28% of college students with the jobs work for less than 4 hours per week. And then because 2.28% is less than 5%, or this is in the bottom 5% of the curve, and we consider that to be significantly low, or this is an unusual event. So anything that is between this middle area is considered to be usual events. And anything that are outside or at the top 5% or the bottom 5% is considered to be unusual events. So this problem, we have the case for an unusual events.